So here's how I'm going to approach this. I'm going to say that these distances here are 1. And of course that diameter is 2, so that means that this distance is 2 and this distance is 2. So notice that the whole circle has a radius of 4. So the entire circle has an area of 16 pi. And it has 3 holes in it. This is a hole with an area of pi. This is a hole of an area of pi. This is a hole with an area of 4 pi. So the shaded area would be 16 pi minus pi minus pi minus 4 pi would be 10 pi. And so the shaded area is 10 pi. The whole circle is 16 pi. And so 10 divided by 16 would be 5 divided by 8. So that's the fraction, but we want 5 divided by 8 as a percent. So writing that as a decimal, that would be 0.625 or 62.5%.
Okay, let's begin with column B, the area of a triangle. To calculate this area, we'll use the following formula. And the question tells us that this triangle has base 5 and height 10. So we'll plug these values into our formula to get an area of 25. Now on to column A. We're looking for a rectangle with perimeter 20. Well, there are many possible rectangles that satisfy this condition. Here's one possible rectangle, and this rectangle has area 16. So using this rectangle, we see that column B is greater than column A. If we examine our possible answer choices then, we can now eliminate answer choices A and C. Now let's find another rectangle with perimeter 20. Here's one such rectangle. Now notice that this shape is a square, but that's okay, because squares are types of rectangles. So this rectangle has perimeter 20, and it also has area 25. So using this rectangle, column A is equal to column B, which means our final answer then must be D. As you will see, the cow has access to 3 distinct regions. We're going to examine each region individually. First, notice what happens when the cow travels both clockwise and counterclockwise. It has access to the following region. This region is 3/4 of a circle with radius 5. So the area of this region will be 3/4 times pi times 5 squared, which simplifies to be as follows. Now let's examine what happens when the cow continues to move in a clockwise direction. At this point right here, the rope will begin to wrap around the edge of the shed. I want to know the length of the red portion of this rope. Well, we know that the entire length of the rope is 5, and this side of our shed has length 3. So the red portion of our rope must have length 2. So if the cow continues to move, it has access to the following region. This region is 1/4 of a circle, and that circle has radius 2. So the area of the pink region will be 1/4 times pi times 2 squared, which is equal to pi. Finally, let's examine what happens when the cow moves counterclockwise. At this point right here, the rope will begin to wrap around the shed, and the cow will have access to this region. This region is 1/4 of a circle, and this circle has radius 1. So the area of the yellow region will be 1/4 times pi times 1 squared, which is equal to 1/4 pi. So the total area that the cow has access to will be the sum of our 3 areas. And this simplifies to be 20 pi. So our answer is E. Alright, let's begin by adding some angles to our diagram. We'll add this angle and this angle. Now let's focus on this triangle right here. We know that all 3 angles in a triangle must add to be 180. So we can write the following equation. Now notice that angle B and angle X lie on the same line. As such, they must add to be 180. So we can write this equation. Now we have 2 equations, and both equations are set equal to 180. Given this, we can combine both equations to get the following equation. And now from here, I'm going to subtract b from both sides of this equation to get y plus a equals x. This tells me that x must be greater than y because we must add a to y for that side to equal x. So x is greater than y, which means the answer here is a. Let's begin by connecting points A and D. Here we can see that the length of AD then will be 12. Now if our angle DAB is 90 degrees, we know that this angle here must be 60. Similarly, if the angle ADC equals 90, then this angle must be 60. Now let's focus on this yellow triangle here. We already know two angles, so we can calculate our third angle to be 60 degrees. Notice that all three angles are equal to 60 degrees. So our yellow triangle is an equilateral triangle, which means that all three sides must have equal length. So if length AD equals 12, then we know that AE must equal 12 and DE must equal 12. We now have enough information to calculate our perimeter. Let's remove this extra information here. We can now see that our perimeter is equal to 60. So our answer is E. Alright, to begin, let's let this angle right here equal x degrees. Now since we have two angles on the same line, we know that their sum must be 180 degrees. So as such, we can write the following equation. Now notice that we have three angles in a triangle, and their sum must be 180, so we can write this equation. Now notice that we have two equations here, both set equal to 180. This means we can combine these equations to get the following. From here, we'll subtract x from both sides to get a equals c plus d. Now we can go to column B and replace c plus d with a. So we're now comparing a plus b with a. Well, since a and b are both positive, we know that column A must be greater than column B, in which case our answer is A. Since the question does not tell us the size of the original triangle, let's let our original triangle have sides of length 10. Now, when we increase the length of each side by 50%, our new triangle has sides of length 15. Now we want to compare the areas of these triangles, so we need our formula for finding the area of an equilateral triangle. When we plug our information in for the blue triangle, we get the following area. And when we plug our information in for the red triangle, we get this area. Notice that both areas are products involving root 3 over 4. Since we want to determine the relative increase in areas, we can ignore these and consider the areas to increase from 100 to 225. To calculate the percent increase then, we need the change in area divided by the original area. This is equal to 125 over 100, and when we convert this to a percent, we get 125%. So our answer is.
So one rule we need to keep in mind for this problem is that any side of a triangle must be shorter than the sum of the remaining two sides. This is called the triangle inequality. So we'll keep this in mind. So we'll try the first one, A, which of course is just 1/2. So we have sides of 1, 1/2, and 1/4. And 1/2 plus 1/4, they add up to something less than 1. So this violates the triangle inequality. We could not possibly have a triangle with those three sides, 1, 1/2, and 1/4. So A is out. A is not possible. B is very easy to check. B, it's just 1, 1, 1. That's an equilateral triangle. That's certainly possible. C, well, this is tricky. This is 3/2. If we have to square something, it's always easier to change it to a fraction. So we're going to be comparing x squared, x, and 1. Well, we'll get 9/4, 3/2, and 1. Well, 1/2 plus 1 plus 3/2, that's 5/2, or 2.5. 9/4, well, 8/4 is 2, so it's a quarter more than 2, so it's 2 1/4, or 2.25. So it turns out here that the sum of the two sides is in fact greater than the third side. If we add up the two shorter sides, it is larger than the third side. So that does work. Now, as soon as we go to 2, though, we get 4, 2, and 1. And here, of course, if we add 2 plus 1, we get something less than 4. And so this violates the triangle inequality. Well, of course, what's going to happen as we get bigger than 2, x squared is going to increase faster than x. That's just what happens. It's going to increase faster than x, and so that means that bigger side is going to get even bigger. For example, by the time we go up to 3, we get 9, 3, and 1. And 3 plus 1 isn't even pretending to be close to 9. 9 is much, much bigger. So we can eliminate all these others without even checking them, and the only possible answers are B and C.